In this video, I would like to introduce how we're going to use proportional reasoning throughout the course of chemistry. It's a key skill. There's so much of chemistry where we can use proportional reasoning to solve even very complex problems with this simple procedure. So I'm going to introduce it now as in the early stages of this and just show you how we can use it with density. And then, of course, this is going to be something just throughout. Using proportional reasoning to solve chemistry problems. Let's look at a typical one that where you probably were first introduced to proportional reasoning way back in elementary school even. I want to convert 3.20 inches into centimeters. So just a simple unit conversion. Let's do two methods. There's two methods to do this. One is through canceling of units, and I'm going to show you that first, and then we'll go through proportional reasoning just to show these two methods in a simple example. So if I were to look at this and I have my conversion 1.00, I'll go ahead and put my sig figs. 1.00 inches equals 2.54 centimeters. That's my relationship, that's the conversion factor from inches to centimeters. And of course, since they're equal, I can put one over the other. I can put 1.00 inch, 2.54 centimeters. Since they're equal, it's equal to 1. If I put one over the other, two equal things. 2 over 2 equals 1. Right, so that's equal to 1. And because they're equal, it doesn't matter which two I put over which two. If they're equal, 1 over the other equals 1. 2.54 centimeters equals 1.00, or over 1.00 inch equals 1. So let's use the conversion factor method to solve this problem, this conversion problem. Of course, nowadays we just go to Google and solve it, but let's do it the old-fashioned way. And so I'm in inches, 3.20 inches, and I'm going to multiply it by 1 so that it doesn't change its value. Multiply it by 1 to get out of inches and into centimeters. So I'm going to use this relationship because when I multiply, the inches unit will cancel. And I will multiply that through. The inches cancel. I'm into centimeters. I plug that into my calculator and I get 8.128. I've got 1, 2, 3 sig figs in my answer. Never let conversion factors limit the sig figs. Here's what limits my sig figs, 3.20. My original value. Sig figs, don't let them limit, conversion factors don't let them limit your number of sig figs. Let's round this to 3, 1, 2, 3, round the 8 up, 8.13 centimeters. 3.2 inches converted to centimeters is 8.13. Let's do this as a proportional reasoning. So that was just canceling. You'll see a lot of chemistry textbooks and such will have do unit canceling. I prefer proportional reasoning because it's it'll help us really pick apart some really difficult problems, and we'll kind of think, well, let's think of it proportionally. So let's do this as a proportion. 1.00 inch is to 2.54 centimeters as 3.20 inch is to x centimeters. When I multiply that through, I can see 1x, and that I'm really getting the same answer, right? It's 2.54 times 3.2. Rounded comes to 8.13. So we can solve these kind of problems with the unit cancellation or the proportional reasoning, but this is the one that I'm going to demonstrate in the class when we get into things like counting atoms and all that stuff. So let's apply that to density. The density is equal to the amount of matter over the volume that it occupies, right? So if I were to take, so we of course can solve density problems just using algebra. If I know the volume of the density, I can find the mass. If I know mass and volume, I can find density. If I know the density and the mass, I can find the volume. So all of that could be done with algebra, let's use proportional reasoning on a couple of problems. Let's say I'm working with lead metal. So I look up lead, and I find that for every 1 cubic centimeters, and I'm going to, that's 1.00 centimeters, there is a mass of 11.34 grams. That is the density of lead. For every 1 cubic centimeter, there are 11.3 grams of matter. And so I could do something and solve like this. Let's just, no plug in equations, or really, this is proportional reasoning that we'll do. Let's say I've got a bigger cube of lead, 2.00 centimeters on a side, right? It's a cube, 2 by 2 by 2, 2.00. So I've got this bigger cube of lead, and I find the volume, and I say, well, the volume of a cube is side cube, 2 times 2 times 2. Volume equals 8.00 cubic centimeters. Now, without doing any, even plugging in here, or just, we're doing proportional reasoning now, but say, we don't even have to like plug it into a ratio. If 1 cubic centimeter has a mass of 11.34 grams, I have 8 of those cubic centimeters in this bigger cube. I have 8 times the volume, therefore I have 8 times the mass. So 11.34 times 8.00. And you get like 90.7. So this thing, solving it that way, say, oh, it's going to be 8 times 11.34, right? And so that makes sense. Let's set up now as the ratio. .34 grams is to 1 cubic centimeter, as x gram is to 8.00 cubic centimeter. What do I do? 1x is equal to 8 times 11.34. So it's the same basic thing. If I plug it in, or in that case, I was able to just in my head say, well, wait a minute, wouldn't it be 8 times as much? And yes. Let's solve another kind of problem, especially when volume is the unknown. A lot of people tend to make mistakes. If I plug in density and I plug in mass into this and try and solve for volume, it's just one of those algebra blocks that some people have. They'll get the incorrect answer. So let's try proportional reasoning with a different kind of problem. I've got some large piece, big chunk of metal, and I weigh it, and it's 47.15 grams, and it's lead metal. I know it's lead. And I want to find what is the volume. If I weigh this thing and it's 47.15 grams and I know it's lead, how much volume is that? I know this relationship because I've looked it up. If I have 1 cubic centimeter, it'll have 11.35 grams. So let's set up our proportion. 11.34 grams is to 1 cubic centimeter. I'm going to leave off the zeros for now, just it's there, right? So it's to 3 sig figs. And then 11.34 grams is to 1 cubic centimeter, as 47.15 grams is to x cubic centimeter. That's our proportional reasoning, right? So I can see it's definitely going to be more than 1 cubic centimeter, and that's a way to make sure I do this right. So let me take you through the steps. I'm not always going to take you through each step. Cross multiply. How do we solve these? Cross multiply. And then, so 47.15, drop the units momentarily, times 1, equals 11.34 times x. Divide both sides by 11.34. Makes that go away. And the answer then would be 47.15 divided by 11.34. I plug that into my calculator. and my calculator said 4.1578, etc. I'm given 4 sig figs in here, and so let's see, my 1.00. Yeah, so actually I've got 4 sig figs and 4 sig figs. So let's round it to 4. 4.158 cubic centimeters. I have to go back to my proportion and said what was my unknown cubic centimeters. Does that number make sense? So there's my answer. Does that number make sense? Yeah, it does, because my mass was definitely a lot more than 11.34. So that number looks okay. That's just our introduction to how we're going to use proportional reasoning, and you'll see how valuable a tool that will be to really dissect. As part of the purpose of the chemistry class is to really work that logical reasoning brain, learn how to pick apart sometimes some long complex problems. And proportional reasoning is one of the key skills that we will use as we go through this course. And let's go to the next step in the next video.